Okay, hey Math 9s, welcome back. In this chapter we're going to be looking at exponents and powers. This chapter 2.1 is going to look at what is a power. Okay, so our focus for this chapter is we are going to use powers to represent repeated multiplication. Okay, so just some shortcuts that you might be familiar with. LOL, we know that if someone writes us something funny, maybe we write back LOL because I just laughed out loud. THX, that's a shortcut for thanks. TMI is, hey, too much info. Too much information. Okay, all these are just shortcuts. Okay, so in math, one shortcut that we use is the exponent. Okay, so the exponent. Now, exponents are just a shortcut for repeated multiplication. Repeated multiplication. We'll keep this in mind because we're going to come back to some exponent laws and different things that get a little bit more complicated later on. And we just always want to remember that, hey, when we're dealing with exponents, that just means that we are doing repeated multiplication. Here's a good example. If we have 6 times 6 times 6, if we want to be more efficient with how we write that, we would just write 6 to the power of 3. Okay, so some vocab to put in your glossary here. The base is called the number we keep multiplying is called the base. The number we keep multiplying. In the above example, that would be 6. Exponent is how many times we multiply it, or how many times to multiply. The base. And in our above example, that's going to be the 3. And the power, a power is just the whole expression. Whole expression. So in our above example, the power is the entire expression with the base and the exponent, or 6 to the power of 3. Okay. Okay, so just a couple of different forms that you can write powers in. We can write that as repeated multiplication and also in standard form. So if we have 3 to the power of 4, if we write that as repeated multiplication, that's 3 times 3 times 3 times 3, 4 times. This little dot in between the 3's is just another way to write a multiplication symbol. In standard form, we can actually calculate that by doing, okay, well 3 times 3 that's 9, and then 3 times, or sorry, if this is 9 and this is 9, then our standard form is just 9 times 9, or 81. Okay, the next example, we have 2 multiplied by itself 5 times, so as a power that's just 2 to the 5, and if we actually multiply that out, we get 32. Okay, if you're looking for, or at 125 in standard form, how do we write that as a power? Well, that can be broken down as 5 times 5 times 5, or 5 to the power of 3. Okay, 7. 7's a prime number, so there's only one power that will work for that, and that's going to be this number 7 itself raised to the power of 1, or just 7. Okay, so multiply that by itself 1 times, and we just get 7. Okay, so on the back side here, it's going to be key for us to identify what exactly the base is, and then that's going to subsequently help us find what the value is. So in this first example, number 1, our base is in brackets, so our base is -3. That's what we're going to multiply by itself. So the first example looks like -3 times -3 times -3 times -3. Okay, so this is negative times a negative, that's positive 9. And then do that again, we have another positive 9. So this value here is going to be 9 times 9, or 81. Okay, in this next example, number 2, there are no brackets around the negative, so our base is just 3. So if we do 3 to the power of 4, that's 81. And this negative out front is going to make the whole expression negative. Okay, in the next example, again, it may look like you're taking -3, multiplying it by itself 4 times, but you're not. The exponent 4 is only being applied on the 3. So this is like having, okay, well, -81 in the brackets, and then you have this negative out front. So our value for this one is going to be a positive 81. And sorry, our base here is just going to be positive 3 as well. Okay. So as we move on here, we're going to get to some more complicated questions. One thing that's going to be key to know is the exponent button on your calculator. Your exponent button on your calculator may look like a little hat like that. It may look like x to the y. It may look like y to the x. It's going to be key to know this button and get to know how to use it. For number 1 here, 7 exponent 4 on your calculator, if you type 7 and then your exponent button 4, 7 exponent button 4, you should get 2401. So make sure to try that on your calculator and make sure that you are able to get the correct answer there. 2401. Negative 4 to the power of 6. Same thing. Try this in your calculator, please, and make sure that you get the correct value so that we're using our calculator correctly. This is going to be crucial. The next one here, this 5 is only attached, or the exponent is only acting on the 4, so 4 to the power of 5 is 1024. Then we had that negative out front, so it should be negative 1024. Okay, so on your calculator, please find that button and fill that in so you know what that button is to use it repeatedly. Okay, just a couple of geometry connections here. Powers with the exponent 2, like 5 to the power of 2 is written as repeated multiplication as 5 times 5. We can think of that as being a square with a side length of 5. And the way that we would talk about this is to say, okay, well, this is just 5 squared. And that's analogous to, or also known as, finding the area of a two-dimensional shape. Okay, powers to the exponent 3. If we draw like 2 to the power of 3, that's just 2 times 2 times 2. That one's special because we can say that's 2 cubed. And the analogy here is that we are going to be finding the volume of a three-dimensional object. So if we draw a cube, label each side length 2, 2, and 2, multiply those together, and we would get the volume. Okay, so the two big ideas here, the big idea for this section is that powers are a shortcut to represent repeated multiplication. Repeated multiplication. Okay, so armed with that new knowledge, give these a try. I've tried to pick select questions here, so like from 4 and 5, just do A and C. You're welcome to do more, but just a couple from those two will be good. Number 9, let's do all that. Then we'll do 13 and 14. We'll just pick every other one, E, C, E, G, and I. You can do 16 and 17, and then a challenge question. Challenge question would be number 20. Okay, so yeah, come to class with any questions that you have, and we'll get going with some practice on exponents. See you then.